Okay, so let us move further to the properties of contour integration. So what would be the properties of contour integration? The properties of contour integration would be similar to that of the definite integration in one variable. So in one variable, you know that your integration holds a linearity property. Here also there will be linearity property. Let's say I'm integrating fz and gz along a contour C. Okay, so I'm doing some properties of contour integration, and the properties of contour integration would be the same as that you see in your definite integration. That is in your standard 12th you see now. So that is the same. So if you are having a sum function, so this will you can say preserve the linearity. There's a preservation of linearity. So if you're doing a sum, if you are finding an integration of sum of two function, it will be equal to integration sum of two sum of the integrals. So if I'm finding the integration of a sum function, it will be equals to sum of two integrals. Okay, so linearity will be intact. If you multiply your function with some constant a and integrate it, so your constant would come out simply the property that you know from your definite integral class also. And similarly, if I write a to b integration fz dz, it will come out as minus b to a fz dz. Okay. And if I write, let's say, if there is an intermediate point, let's say if there's an intermediate point, m, lying between a and b, then I can write a to b fz dz is equal to a से लेकर m fz dz plus integral m to b fz dz. So all these properties would remain the same. So I don't need to, I'm not going to get into derivation part, but just understand all these properties. Okay. Now let us move forward to something called as ML inequality. ML inequality. So understand that if consider a function fz, okay, consider a continuous function fz on curve C, satisfying fz mod is less than equal to m. That is, on the curve C, my function has attained some maximum value. Let's say that is m. Okay, my function attains some maximum value m, and I'm evaluating a contour integral I given by integration fz dz. Okay, then what will be the answer? The question is, what will be an estimate, or I can say what will be the you can say upper bound of absolute value of this integral. So what would I do? I would simply take I mod. I mod is integration C fz dz mod. Yes or no? And you just remember there is a property in integrals. So I'll use that right away, but I'll not make you derive that. But understand this is a property from A to B. Okay. So what it would do, I know clearly that my fz ka mod is less than equal to m over contour C, and let's say C moves from A to B. So my curve C is moving from z equal to A to z equal to B. Okay. So this particular thing is less than equal to m. So this will be less than equal to m. Integration mod dz from A to B. So mod dz hai kya? So your curve is divided into small divisions, and all these divisions are dz. और इन सब का magnitude लेना मतलब क्या? इसकी length लेना. So dz का mod represent the length of the subintervals. And all these length when added from A to B would eventually give me the length of the arc. So what will be the upper bound of the absolute value of the integral fz dz? That would be always less than equal to ml. So upper bound would be ml. So this is called as ML inequality. This is called as an ML inequality. Let us understand this particular thing using an example. So let us do an example for understanding this. Okay, are you getting my point? यहाँ तक समझ में आया कि सब ऊपर से ही जा रहा है? अल्पा ही है तो Bharat is not there. Is that audible? Am I audible? Am I not audible? Who's there? Don't think somebody is there. If somebody is not there, Alpna is there, no? समझ में आ रहा है बेटा? नहीं आ रहा है?
हाँ मुझे नहीं, हाँ वो तो आ रहा है। मेरे को ऐसा लगता है कि उन लोगों को पता ही नहीं इस वाली क्लास का। आप लिखो ना उसमें मैसेज में।
Okay.
मुझे वो डाउट जा रहा है।
तो तू लिख देना वहीं से फटाक से।
And if you want to continue,
अच्छा, okay, I'll have to do
हाँ
it.
मैं लिख
Right?
देती हूँ।
हाँ. Okay. So this is ML inequality. Now
I'm
further,
right.
you just write it. So how would ML inequality behave? So let us do a question to understand. ठीक है? जैसे कि a simple question लेते हैं. Let us do a simple question first and then move ahead. Tomorrow we'll do residues, so we'll be close to our integration side. ठीक है? So how would we do?
वो लास्ट वाली जो लाइन बोली थी ना वो।
Okay,
हेलो
I'll repeat it again. ठीक है? What I'm
भैया।
saying is, हाँ बेटा बोलो. Yes.
हाँ
Yes, yes. Yes, yes. देखो मेरी बात समझने की कोशिश करो. I'm saying ML inequality. I'm teaching you ML inequality right now. ठीक है? ML inequality means I'm saying my function fz is continuous on C. Okay? My function fz is continuous on C. So my closed curve is C. This is my not closed curve, sorry. This is my curve C. So this is my curve C, sorry. This is my curve C. Okay? And my function fz is continuous on C, such that my function holds some maximum value. That is, I am saying that on the closed curve C, function is maximum somewhere. I don't know where, but there is a maximum. There is a maximum. There is a maximum for the function fz. So अभी के लिए ऐसा समझो कि फंक्शन का मैक्सिमम होल्ड करता है, कोई ना कोई मैक्सिमम है. लेट्स से दिस इज m. So fz का मॉड विल बी लेस देन इक्वल टू m, राइट और रॉन्ग? So fz, the absolute value of function holds some maximum. Let's say fz का मॉड is less than equal to m. Okay? On curve C, I am trying to find what will be an upper bound of the absolute value of this integral given by integration fz dz over this curve C. So what I would do, I would simply take a mod. I mod would give me integral C fz dz mod. And there is a property in integration, I'm not going to derive it, that this mod will be less than equal to individually अंदर की तरफ mod लेना. Okay? So I would say that integration fz dz mod is less than equal to integration fz ka mod and dz ka mod. Further, I already know that fz ka mod is less than equal to m, so I would write less than equal to m. M is a constant, I will take it out. Integration dz mod from a to b. What is dz mod? So dz was nothing but these were length of the subintervals, right? These were length of the subdivisions, you can say. Okay. All these lengths taken absolute means what you are doing, you are just writing dz mod means you are just writing the length of the subinterval. All these length of the subinterval from a to b when integrated would give you the length of the arc. This length of the arc, let's say I'm seeing as L. So I would say that my I mod is less than equal to ML. This is called as ML inequality. Okay. Yes or no?
ऊपर से ही.
Okay. ज़्यादा नहीं आएगा इस एग्जाम में. So I'll only do 2 or 3 questions over it and we'll move ahead. So let us do one question. Find the upper bound.
सर ये फिजिक्स में भी है क्या?
हाँ, फिजिक्स में भी है. Find the upper bound of, पर difficult questions नहीं आएंगे, don't worry. Absolute value of integral. यार तुम दोनों थ्योरी से हो, तुम दोनों मैथ से डर रहे हो, क्या कर रहे हो? What would you do?
सर डर नहीं रहे लेकिन
Where C,
एक साथ बहुत सारी इंफॉर्मेशन चली जाती है अंदर, वो प्रॉब्लम हो जाती है.
C is the line segment. आज ही के दिन है यार. Because 2 days probably we will be busy. Like in our colleges, there are some like there is an annual presentation sort of thing. So probably I will be able to spare only a single lecture for 2 days, like 28 and 29. So after that, we'll be taking three lectures. But today, from like 28 and 29, we'll not be able to spend more than one lecture, because that is an issue. So that is why I'm taking 3 today. Probably I'll take 3 tomorrow, and then we'll have only single lectures for 28 and 29. 30th onwards, we'll do whatever we are doing. My target is anyhow we should start with this quantum mechanics. One lecture we'll keep a reserve for differential equations. So one side I will teach you differential equations, so that any sort of input from differential equation when it comes to your quantum mechanics will be a helpful thing. Okay. Okay, so find the upper bound of the absolute value of integral I is equal to integral e to power z dz over contour C, where C is the line segment joining. The points are given 0, 0 and 1, 2 √2. Okay. Achha, anyone who's interested in experimental magnetism, kindly let me know. Okay. So kindly let me on the group. Anybody who wants to join a project in experimental magnetism, okay, especially on critical phenomena and on skyrmonionic systems. So if anybody is interested there, kindly let me know. No? So that you do on your my WhatsApp account. If you have anyone, like anybody who is interested in working in magnetism, so kindly let me know. So I is equal to integration from C e to power z and dz, where C is the line segment joining 0, 0 and 1, 2 √2. You have to find what will be the absolute value of this integral. So देखो पहली चीज मैंने क्या लिखा था, इंटीग्रेशन पहले समझते हैं, fz dz ओवर कर्व C, इसका जो मॉडुलस है इट इज ऑलवेज लेस देन इक्वल टू m into n. m यहाँ पर क्या था, it was the maximum value of the function, maximum value of the absolute of the function. L was the length of the arc. बात खत्म, यहां तक समझ गई? सो पहले एक काम करते हैं, पहले m पता करते हैं. सो fz क्या है यहाँ पर बेटा, e की पावर z, और fz का मॉड विल बी व्हाट, fz का मॉड विल बी इक्वल्स टू व्हाट, e की पावर x प्लस आयोटा y का मॉड मानते हैं, and that will be equals to e की power x into e की power iota y का mod, yes or no? And that will be e की power x. Okay, yes or no?
yes.
Okay. अच्छा, थोड़ा ध्यान से देखें, इस पूरी लाइन सेगमेंट में x कहां से कहां वेरी कर रहा है, x is varying from 0 to 1. देखो, x is 0, y is 0, x is 1, y is 1. So x is varying from 0 to 1. So what will be the maximum of fz? So maximum of fz would reduce to saying maximum of e की power x when x lies between 0 and 1. Right or wrong? Maximum fz is actually writing maximum of e की power x. और x कहां से कहां वेरी कर रहा है, 0 से 1. और e कैसा फंक्शन होता है, एक्सपोनेंशियल इज एन इंक्रीजिंग फंक्शन. तो 0 से लेकर 1 के बीच में इंक्रीज करेगा, मैक्सिमम वैल्यू कहां पकड़ेगा, 1 पे. e देखो x कहां से कहां वेरी कर रहा है, 0 से लेकर 1 के बीच में. So e की power x will take the maximum value at 1 in the interval 0 to 1. Yes or no? So m would be equal to e. ये तो हो गया, काम खत्म. m तो मिल गया तुमको, yes or no?
Yes.
ठीक है. अब मान लेते व्हाट इज l. l क्या था, इट वाज द लेंथ ऑफ द कर्व. तो लेंथ ऑफ द कर्व क्या है, इट इज सेइंग इट इज अ लाइन सेगमेंट, तो लाइन सेगमेंट बना दिया. Joining the points, I think 0, 0 and 1, 2 √2. So what will be this length of curve? This length of curve L would be nothing but it is equal to root over 2 √2 minus 0 का स्क्वायर. यहाँ तो लाइन ही है ना, लाइन में क्या होता है, x2 minus x1 plus y2 minus y1. So this will give you, I think 2 √2 is 8. This is 1, 9. So this is 3. So what will be the upper bound of the absolute value of this integral? It will be less than equal to m. Sorry, it will be less than equal to m into n. So it will be less than 3e. So it will be less than equal to 3e. Yes or no? ये बात समझ में आई? Are you getting my point?
हाँ भैया.
Okay. Okay.
पर ये
एक
काम
और,
करता है.
हाँ जी, हाँ सब काम का ही.
हाँ नहीं काम करता है, नहीं काम का मतलब अपर बाउंड मतलब कैसे, मतलब एग्जैक्टली
अपर बाउंड मतलब, जैसे अपर बाउंड मतलब देखो, maths में या physics में we are always interested in finding what would be the maximum value of the function and what would be the minimum value of the function. इसको हम loosely बोलते हैं upper bound. मतलब loosely, I'm saying loosely मतलब loosely. मतलब let's say I'm saying sin x lies between 1 and -1. So I would say this is an upper bound. 1 is an upper bound. -1 is a lower bound. इसको bounds बोलते हैं, है ना? बहुत technically speaking, this is least upper bound, this is greatest of lower bound. So this is supremum, this is infimum. So I don't want to delve into all those things, but I'm saying 1 would be an upper bound, yes or no? -1 would be a lower bound, yes or no? So interest in physics, in mathematics, at times would be to find maximum value. Let's say, even if you're doing any physics problem, let's say optimization problem, and you want to find what is the maximum or what is the minimum. So in any case, such kind of arguments are important. So therefore, I'm writing an upper bound. Upper bound matlab integral के absolute की maximum value क्या हो सकती है, maximum possible value क्या हो सकती है. So this is a maximum possible value. In any case, the absolute value of integral will always be less than equal to 3 times e. This is an estimate of the upper bound that ML inequality gives me. Are you getting my point? समझ में आया नहीं है, ऊपर चला गया. So I would not be able to give you a physical insight to it, but I would say that such kind of queries are very important in mathematics and physics. That is, what would be the maximum value of integral? What would be the maximum value of function? Because they may be of some use somewhere. So that is why you can take that as an inspiration. बात समझ में आई कि ऊपर से गई है? कोई कुछ बताता ही नहीं है. समझ में आया बेटा? नहीं है तो बताते हैं.
हाँ भैया.
ठीक है. नाउ देखो contours में please remember this, there is something called as clockwise and some anti-clockwise orientation, anti-clockwise traversals. So you can traverse in closed contours, you can traverse in clockwise direction and anti-clockwise direction. ठीक है, समझ में आई बात? So in the whenever you are moving in a closed curve, you can either move clockwise or you can move anti-clockwise. So positive sense is said to be the anti-clockwise orientation. So positive sense is called as anti-clockwise orientation. So in examination or otherwise, if I say I'm moving in positive sense, it implies I'm moving anti-clockwise, and it means a lot. There was a question in exam which just went wrong. Most of the students did wrong because they could not assess the orientation. So understand, if I'm moving anti-clockwise, that implies my curve would lie on the left-hand side of my orientation. So let's say if I'm moving this way, anti-clockwise, I'm moving anti-clockwise, so my curve is on the left-hand side. Okay. So I would write, so if I'm saying I'm moving anti-clockwise or counterclockwise, so I would say that my contour would always lie left as I move along. So if I am traversing my contour in counterclockwise sense, that is a positive sense, my curve will lie on the left hand. So basically what is happening, this is called as positive sense of moving. So if somebody says that integrate over some closed contour C and it is anti-clock sense, then answer would be positive. And if the same question comes and if someone says that I am traversing on the contour, closed contour clockwise, then the same answer you have to declare in negative. Okay. So these sense are very important. You have to remember this, that if I'm saying positive sense, it means I'm moving anti-clockwise on the closed contour, and the answer would come as positive, or whatever. You have to just put positive here while evaluating it. And if I'm moving in the clockwise direction, whatever the answer comes, I have to multiply it with negative, because now I'm moving in the clockwise sense. The clockwise sense is called as negative sense, because now the angles are decreasing. Here angles are increasing. So this is a sense that has been taken. So you have to adopt that. There is no explanation in this. Just understand the anti-clockwise sense is called as a positive sense. While moving anti-clockwise, you can clearly see initially you can see that your curve is lying left to your sense of moving. Okay. And in clockwise sense, your curve lies to the right while I'm moving. Okay. Understand the point that anti-clockwise sense of traversal is told as a positive sense of rotation, and clockwise sense of rotation is called as the negative sense of rotation. So whenever I'm moving clockwise, I have to multiply with the negative, and if I'm moving with the anti-clockwise, the answer is whatever it comes is an answer. But whenever someone says I'm moving clockwise, you have to multiply with a negative also. Okay, because that is a negative sense of rotation. Are you getting my point? This holds only when you are moving on the closed contours. Yes or no? इसको समझ में आ रहा है ऊपर से ज्यादा? Yes or no?
Yes, sir. Yes.
Okay. A few more questions on this kind of thing. So just give me an answer to this. Evaluate dz upon z. Evaluate dz upon z around a unit circle. Around a unit circle centered at origin. Around a unit circle centered at origin. Okay, so how would you go about it? So unit circle centered at origin. So if I have origin here and there is a unit circle, so any of the point on the circle can be written as e ki power iota theta, mante ho? So any point on the unit circle can be written as r e ki power iota theta, and r is 1. So e ki power iota theta, yes or no? And dz would be then iota e ki power iota theta d theta, yes or no? So this will be integration over the closed contour iota e ki power iota theta d theta divided by e ki power iota theta, yes or no? And this gets cancelled. It will give me what? Iota integration over closed contour d theta. So integration over all this closed contour, theta would vary from 0 to 2 pi. So this will give me 2 pi iota. So answer is 2 pi iota in general. Yes or no?
Yes, sir.
Haji, समझा बेटा?
Yes, sir.
And the positive sense of rotation. If I'm making a positive sense of rotation, answer is plus. If I'm making negative sense of rotation, if I'm saying just evaluate this contour in the negative sense or in clockwise sense, then answer is negative. So if at all somebody says, find me a contour integration over the closed contour, by default, we will say that we are moving counterclockwise. Okay. So there will not argue. But if somebody says that find me this integration clockwise, find me this integration while I'm traversing the closed contour clockwise, then I have to declare it minus 2 pi. The answer to be minus 2 pi. Yes or no? Just try to find me this integral. What can you say about this integral? dz upon z raised to power n, where n is some value greater than equal to greater than 1. Let's say I will write n equal to 2, 3, 4, so on. Find me this answer. We'll extend some ideas from here and we'll move to the calculus of residues. So that is why I'm making you do all these questions. These are very easy questions, but still. Because I'll take an inspiration from here only while I'll be moving to the calculus of residues. So therefore, I'm just making you do all these things. What will be an answer to this? What will be an answer to this? So clearly, again, I'm moving on the unit circle. If I'm moving on the unit circle, my z will be equals to what? E will be equals to e ki power iota theta. Dz will be equals to what? Iota e ki power iota theta d theta. So I'll simply write iota e ki power iota theta d theta divided by, I think, z ki power n. So iota n theta d theta, right? So this will give me iota e ki power minus iota. I think this will be n minus 1 theta d theta. Yes or no? This will be, you'll take it, इसको ऊपर ले जाएं, you'll write this way. Okay. And so what will be in integration? So e ki power theta integration is e ki power theta itself. So answer will be e ki power minus iota n minus 1 theta upon minus iota n minus 1. Okay, so theta is multiplied with this. In derivative, we multiply it in chain rule, and in integration, we divide the coefficient of theta. Okay, from where to where? 0 to 2 pi. Okay, this will give me, I think, 1 upon 1 minus n, and this will be e की power minus iota n minus 1 into 2 pi minus e की power 0. 2 pi multiplied with anything, like any any of these integers, will give answer as 1. E की power iota 2n pi is 1. E की power 0 is also 1. Answer will be 0. Yes or no?
यस सर।
कल्पना को समझ में आया? ऊपर से चला गया?
हाँ भाई आ गया।
ओके, चलो एक क्वेश्चन करो ML इनइक्वालिटी पे। ओके